welcome back everyone. We are going to run through 9-1 pretty quick here because most of this should be review from Math 8. So these original formulas that you have here, most of them should be familiar, that your perimeter and your area for each of these three different shapes, and then circles are where it gets a little tricky. So make sure that you remember that our circle formulas, we have 2 for circumference. We can either use pi times the diameter, or we know that since the diameter is actually double the radius, we could use pi times 2 times the radius. And area, I always like to remember, if it's a circle, it's going to involve pi. And since it's area, something has to get squared. So it's always going to be the radius squared. So make sure that you just pay attention to using the correct formula in each situation. So when you look at problem 1 here, we need to find the perimeter and the area of this rectangle. Now perimeter is fairly easy when we have rectangle. It's going to be 2 times whatever the length is and 2 times whatever the width is, because we know that the length and the width will each have matching partners on the other side. So what I do here to figure out the length is I say this x value is 6 and this x value is 1. So to find my change in x, or that distance, I can just do the x2 minus x1, and that gives me that distance is 5. So I know that both of those are 5. I can do the same thing with my y values and check that the 6, oh come on green. Let's see if we can get green to work. Haha. Nope. Alright, we'll go to red. My y value is 6 and my y value is 2. The difference between them is 4. So I see that's 4 and that's 4. So I come back to my formula and I say, alright, it's 2 times the 5 plus 2 times the 4. This is 10 and this is 8. So my perimeter ends up as 18. And because we do not have units, you could just write units if you want, or you don't necessarily have to, but we like to have units. So ideally that would be inches or centimeters or something like that. So then area. Area for a rectangle should be fairly easy if you remember from Math 8. But area is always length times width for any two-dimensional square, rectangle, parallelogram. I mean, we can really manipulate this to a bunch of different situations. So my length we already found out was 5. My width we found out was 4. 5 times 4 is 20. Now this is where the label really starts to matter. My area is 20, but I need to give this a label. You know what my label would be? Units. Squared. So I'm just going to put U squared for unit squared. Because the thing is, it can't just be units, because it's area. It's the difference between how far away something is and how much space something takes up. So always make sure that, especially on area, you gotta have that label. So on the got it problem, go ahead and try this on your own. I tried to be nice and give you a coordinate grid on your graph. So if you are watching this at home, pause the video, take a moment to try this on your own. I'm going to go ahead and start placing these points up here, and then we will talk through the solution. I is at -5, 2. J is at 2, 2. And K is at 2, -3. Now the nice thing about when I draw it on my own is I can just kind of count how long this is. So I can count 1, 2, 3, 4, 5 as I go vertically, and 1, 2, 3, 4, 5, 6, 7 as I go horizontally. So I know I need to find the perimeter and the area. So again, my perimeter is going to be 2 times my length plus 2 times my width. So my length is 7 and my width is 5. And sometimes we like to use parentheses just to clean things up a little bit. And I get that my perimeter is 24, and again I don't have any units for my label, so I can just put units. Area, again, we know is just the length times the width. My length was 7, my width was 5. My area becomes 7 times 5, which is 35 units squared. Make sure that you have that square on your label. Now this really only gets tricky when we go to triangles, and I want to stop here because we have a rectangle that is nice to look at. If I turn my rectangle into a triangle and kind of ask myself, what's happening here? How much space is taken up? I see I end up with a partial box right here, and a partial box right there, and then a partial box right there, and most of the box right there, and a partial box right there, and so what I see is if I took all these partial pieces and put them all together, I would end up being able to match up and make total boxes. And then the other full boxes that we have left, if I add up all of those and compare it to the other side of the rectangle, you should be able to see by how this looks, the area of a triangle is just half of a rectangle. So when we look at that formula for triangles and say it's 1/2 the base times the height, that's where that formula derives from, is that a triangle is just half of a rectangle. So moving on to circles, finding circumference, there are two ways to do it. We're going to look at both ways here. B, you can actually just find the diameter and then go from there, but we'll look at both methods. So my one common formula that I have, there we go, for circumference, and the way that I remember this is crust equals pi dough. Is the easy way to remember it. The crust is the dough of the pie. So if you remember crust equals pi dough, I stole that from another math teacher, then that will help you remember the circumference formula. So, actually I stole that from Danica McKellar. If you guys ever watch, it's either Hallmark Channel or Lifetime, but she's actually becoming an actress now. But she's a really good, really well-known author and female actress, and like she does a lot with like math education. So she's got cool videos too. So I have my diameter here, so I can use this formula. Now here's the most important part of this question. What does it mean to be in terms of pi? Any of you guys know? Those of you who are here in person? Yeah?
I think that it means that you do not convert pi to 3.14 and you leave it at pi.
You leave pi exactly how it is, which makes my job really easy. Because now all I have to do, in mathematics, we like our constant values first. Now yes, pi is a constant value, but because we're still using the Greek symbol, I'd rather write 15 first. So I write 15 pi, but then do I have a label for length in this circle?
Label for,
I have inches here, right? So this circumference would also be inches. So I go ahead and say that my circumference would be 15 pi inches, which throws people off because like, how can I have pi inches? Well, all that's telling me is it's 15 times pi, approximately 3.14, that many inches. So this would be close to 45, 46, right about there. But we can just leave it as 15 pi because it asked for it in terms of pi. So try B on your own. Pause the video. Otherwise, I'm going to dive in. I'm going to show two different methods here. Because I have the radius, I'm going to show the method using the radius, but I can also use the radius to find the diameter. So if I use my radius formula, pi times 2 times the radius, my radius is 4, so I can go ahead and replace it with that. 2 times 4 gives me 8. I can go ahead and swap this around. Say it's actually 8 pi. Check for a unit. I have centimeters up here. So it's 8 pi centimeters. Now the other thing that I could do is when I start this problem, I could say, well, if the radius is 4, then I know the diameter is twice the radius, or it's 8. So then I could set up crust equals pi dough, and just say, well, my diameter is 8, circumference is 8 pi centimeters, and be done. Same answer, two different ways to get there. I can either use the radius and plug it into the formula that involves the radius, or I use the radius to derive the diameter, and then I plug in the diameter to the diameter formula. Hopefully circles make sense, finding circumference, especially when you leave it in terms of pi, it's easy. If it didn't ask you to leave it in terms of pi, just do the multiplication and then simplify from there. Go ahead and try this, got it. It does not show you the circle, but it tells you that it has a radius of 24. So just like what we just did, you choose the method that you solve this with. Pause the video, give this a shot. I'm going to go ahead and start rolling. I like using my crust equals pi dough formula. I think it's easy, it will always work, and I can either have the diameter given to me or I can find the diameter. So here, I'm given the radius. If I'm given the radius, I know that I can find the diameter because it'll be twice the radius. So if my diameter is twice my 24, my diameter is 48, and I have a label. Make sure to bring that label with you. My diameter is 48 meters. That is one large circle. Yes.
Pi.
That's not involving pi yet because all I was doing was finding diameter. That's not my answer yet. All I was doing was finding diameter. So if I think about what the circle looks like, I have a circle that what they told me, this is 24. What I just found out is that this is 48. So we're not at our answer yet. This is what I call a working number. It's a number that I'm gonna need. That's why I put it in a circle, and that's what probably threw you off, is I'm not done yet. I'm just circling that so I know I'm using that. So what I do then is come over, drop that answer into my diameter, pi times 48, and that's 48 meters. So this flips around and becomes 48 pi meters. Now we're done, and that is my answer. So remember, circumference, circum means distance around or just to go around. So if you were asked to circumnavigate something, you'd go around it as opposed to going through it, like if there was a really dense forest or something like that. Circumnavigate. So now we deal with triangles. Now this gets a little difficult because of this line right here. If I ask you to find out the distance of that line, it's a little bit difficult.
A squared plus b squared equals c squared.
Exactly. It's a little bit difficult, but it's not very difficult because we know that our best friend Pythagoras told us a way to do this. When I think about my Pythagorean formula, I have a squared plus b squared equals c squared. And this gets us to our distance formula, which we already talked about in a previous lesson, I think in chapter 8. But I don't like just saying, okay, what is the distance formula? I like to figure it out based off what we know. Well, I know that C is my hypotenuse, and A and B have to be my legs. So I'm going to flip this around and say that C squared is equal to A squared plus B squared. But I don't want C squared, I want just C. So the distance, or the length of C, could be found by square rooting both sides. And C would just be the square root of your one leg squared plus your other leg squared. So once I find that sum, I square root it and I know my length. So let's go ahead and apply this. So first off, I need to figure out my A and my B, which that's easier because those are either a vertical or a horizontal. To find my vertical length, we look at our Y values. So 6 to -2. If I did 6 minus -2, it would actually add and tell me that this is 8. So I'm going to go ahead and fill that in for A. So I'm going to say C is radical 8 squared plus, now I need to figure out what B is. Well, then I look at the X values, so -3 to +3, that's a distance of 6. And again, I could also count it since I see the triangle on my coordinate grid. So I have 6 squared. And now I just go ahead and compute and simplify. So I have to do inside the radical before I can apply the radical. A lot of people try to just say, well, this is just 8 plus 6 because the square root cancels out the squares. You cannot do that. You have to follow order of operations. So this is essentially in parentheses in here because we know inside the square root is like a grouping symbol. So I have to figure out what is 8 squared first. 64, 6 squared, 36. What's 64 plus 36? 100. That works out very nicely. What's the square root of 100? 10. So that now tells me that this distance, or this this hypotenuse, has a length of 10. So then to find my perimeter, I can just say perimeter will be the sum of all 3 sides. So it'll be 6 plus 8 plus 10, which actually this triangle is a dilation of our famous 3, 4, 5 right triangle, the perfect right triangle, 3, 4, 5. So this is just double. So the most famous or most common right triangle that we use has a length of 3, 4, and then the hypotenuse becomes 5. So this triangle is just a dilation, a double of that triangle, because I have 6, 8, and 10.
It's perfect.
So we use that in like construction applications. Like say I want to check an angle that I'm making is a perfect right angle. I would measure 3 feet out one board, 4 feet out the other board, and I'd mark those points. And the measurement from that to the other point should be 5 feet. If it's not, I don't have a perfect right angle. So I've actually used that building things is this square. Because you could put a little square up to it's square. But when they're like 10 foot long boards, it's really hard to just put a little square in the corner and trust that if I can measure out 6 feet and 8 feet, that manipulation, and then measure across those points, and that's 10. It's a perfect right triangle. I know it. So then 10 plus 8 is 18, plus another 6 is 24. I don't have any units, so I'm just going to say units for my length. Now, don't worry. Fun is not because we're not just asked to find perimeter, we're asked to find perimeter and area. So I'm actually going to go ahead and clone this page and then clear the ink so we can kind of have some room to work. But I'm going to rewrite what we know up here. So we found out that this is 6, this is 8, and this is 10. Now if you go back to the beginning of your notes and check your area formula for a triangle, it's 1/2 the base times the height, and the big like bells and whistles and alarms in your head that should be going off is the base and the height must be, what does that symbol mean? Perpendicular, right? So this means perpendicular, so I'm going to put parentheses around it and then write it out, perpendicular, in case you forget. But the base and the height, those two measurements that you use, have to be perpendicular. So sometimes the height is not even a leg of the triangle. It's just the distance from the bottom of the triangle up to the top of it. So it doesn't always have to be a leg. Here we do have a base and a height that are perpendicular because we already found out that this is a perfect right triangle. So we know that those are perpendicular, so I can go ahead and plug those in. Area is going to be 1/2 of my base, we'll call that 6, and my height, we'll call that 8. 1/2 of 6 becomes 3. 3 times 8 is 24. So my area becomes 24. Again, we don't have any units, so we would say units squared, or square units. Any questions? Cool. So try this on your own. You want to put all these points onto your coordinate plane and then figure out those distances and figure out, do I have a perpendicular meeting of two sides, or do I have to do something else? So -6, -1, there's my A point. +6, +4. There's my B point. And there's my C point. So if I connect these, so what kind of triangle do I make here?
Okay.
Do I see a right angle?
Right triangle.
Yeah, I have a right triangle, right? Because I know this is a vertical line and this is a horizontal line, so I know that they have to be perpendicular with each other. So what's nice about the horizontal and the vertical, I can just count. How far is this side? Well, 1, 2, 3, 4, 5. So I got 5 on that side. How long is this leg? Well, I can count again, or I can just do the difference. If this is 6, and that's -6, well, to go from +6 to -6 is a total distance of 12, because I know it's 6 to get to 0, and then 6 more to get to -6. Again, though, to find my perimeter, I've got to apply that Pythagorean Theorem. So I want you to try the Pythagorean Theorem. Pause the video and give this a shot. But I know the length of my hypotenuse will be, and by the way, if we were doing labeling this really, we would use capital letters for the points and then lowercase letters for the side lengths. So we would still temporarily call this a lowercase c, and this would be an uppercase c. So the length of c will be the square root of the other legs squared and summed. So we square them, then we sum them, add them together. So 5 squared, I'll go ahead and write out the work. It'll be radical 25 plus radical 144. That becomes radical 169. Check, is this a perfect square? It actually does work out. Radical 169 is 13. So that tells me that C here is 13. And then to find my perimeter, just add up all your sides. So 13 plus the 12 plus the 5, and I get a total perimeter of 30 units. Any questions from that one? Clone this again, but I'm going to not clear all the ink. Now when I'm looking to find the area here, again, the first thing I need to look for is a perpendicular meeting of two of my sides. If I don't have that perpendicular meeting, I will have to draw an altitude. Remember, an altitude is the perpendicular line from one side up to the other. So let's say I had a triangle like this. I don't have any meeting points that are perpendicular to each other, so I can draw an altitude by coming from this point straight down. So that would then be my height, and this would be my base because they have to be perpendicular to each other. Or if I decided to drop an altitude to my from one of my other sides, like say from this point, I could come perpendicular from that side over here. This would then be my height, and this side would then be my base because they have to be perpendicular with each other. So I really end up with three choices, but the triangle that we have right here is already a right triangle, so it works out nice. My base and my height have to be perpendicular, so we know that my 12 and my 5, because they're perpendicular with each other, are my base and my height. So we set up area equals 1/2 base times the height. So we have 1/2. I always like to make my base an even number if possible. It doesn't matter what you call your base and your height because it's geometry. We can rotate, we can move. There is no strict up and down. So I'm going to say 1/2 of 12 times 5. So that's 6 times 5, which gives me 30, and I'm going to write this just a little different, 30 square units. And that would be my final answer for area on that problem. Any questions? Those of you at home, if you have questions, you should be sending them to me. So finding the perimeter of a pentagon. So here, it's just a manipulation of everything that we've already been doing. We have 3 straight lines, like horizontal or vertical here, but then we have 2 diagonal lines. So let's ignore the straight lines right now and look at the diagonal lines. How can I figure out the length of those diagonals? Well, the first thing I want to do is relate them to each other to find out, is there a way to make this easy? Let's look at the triangle that gets formed when I connect, green's not working, when I connect this point to this point. This triangle that I just made comes over 1, 2, 3, 4 and drops down 3. To make the triangle from this point to there, comes over 4, drops down 3, which tells me what about those 2 triangles?
They're equal.
Yeah, they're the same. So they're equal, but better than saying equal, because like in geometry, we'd rather say they're the same or they're congruent. That's the word in geometry that we like to use for the same and equal. So they're congruent. So because they're congruent, I know that the lengths of the hypotenuse are going to be the same. And how do you know that it's 5?
Because you just talked about how it was a perfect right triangle. It's 3, 4, and 5.
This right here is our perfect right triangle. It's our famous perfect right triangle because it's the first right triangle with integer legs or integer sides for all of them. 3, 4, 5. Perfect right triangle with all integer sides. So I could do the math and find out that this is 5, or I just know that it's 5 because it's famous. It's famous and I know it. I know that to be true. So now that I have both of those as 5, I don't care about the triangles that I'm inside. I need to care about my other lengths. I've got a 3 here. I've got 1, 2, 3, and then 1, 2, 3, 4, 5. So I've got a 8 here, and then I've got a 3. Again, I could be using that distance formula, but since we're on the coordinate plane, it's just as easy to count. So then, find our perimeter, add up all the sides. I'm going to take my pairs, 1, 8, then I have 2 3s, and then I have 2 5s. So I have 8 and 6 and 10. So I really have 18 and 6, which will give me 24. Again, I don't have any units. So I just say that my perimeter is 24 units. Now area. If we were asked to do area, if we were asked to do this, easiest thing to do is draw a line, break up the shape into two shapes easier. Now I just have a rectangle, and I can deal with rectangles and triangles a lot easier than some awkward shape like that. You have a face. Does that make sense? Okay. Not you have a face. You have a face. You were making a face. Hopefully you have a face. All right. So go ahead and put this JKLM on LM. Go ahead and put JKLM coordinate plane and try to find that perimeter. So I'm going to try to not say anything else until I have it. You should pause the video and try this at home. Always make sure that you label your points. Don't just put a point on the graph and then forget what it is. Label the name of the point. 4. When I look at finding the lengths of those hypotenuses, however you say hypotenuse in plural, I think it's hypotenuses. I have a leg of 3 and a leg of 4, which tells me that this diagonal must be a length of 5. And this diagonal, having a leg of 3 and a leg of 4, also must be 5. So now when I start adding up all my sides to my perimeter, I have the 5 from the tops, the 5s from the sides, and then the bottom of 6. So my perimeter really comes out 26, whatever units this would be. Good question. Yeah. So area of circle we delve into next. And the biggest thing is you have to use the radius. There's no way to use the diameter except for using the diameter to find out the radius. And then you have to use the radius. So the only area formula we have is I always start by writing the formula because it helps to remind me. Always pi is going to be involved because it's a circle. Times radius squared. Something has to get squared because it's area. So I'm not given the radius. Don't jump right in. Get so excited to solve the problem that you use the 16. I don't want the 16. The 16 is my diameter. And what's my radius?
9.
Close. 8. See, you get too excited. You try to work fast. Goofy up. So pi times 8 squared. Check. It wants it in terms of pi. So we do not substitute for pi. The only thing we do is 8 squared, and that gives me 64. So this becomes 64 pi. Check your units, meters. But since it's area, it's not just meters. It's meters squared.
So I sometimes like to sketch a picture.
It's pretty quick. Diameter of circle is 14. Try to draw a circle. Does not have 14 feet. 14 then tells me what would the radius be. The radius is half of my diameter, so it would be 7. It's asking for the area, so I set up my area formula. Pi radius squared. Would be pi times 7 squared. 7 squared is 49. And then I check for a label feet. So this becomes feet squared. Write out square feet. Any question? We could show the multiplication here between here, but we do not have to. And remember, never, ever, at this point in your mathematical use the x to show multiplication. That is a no-no. And finding the area of irregular shape. All these shapes we call these shapes irregular. They're just like they have feelings. They might look a little different. All right. So the best math professor I ever had. The best math ever had at Otterbein, Dr. Jeffrey Smith. His best advice was always, you don't know how to start. Can you draw a line? Can you break this up into something? Can you extend aside? Can you find out anything? Well, one thing that I immediately notice is all of these tick marks. Boom. Equal. And boom. So exactly like Alex, all of these green tick marks are all equal to each other. So since this tells me that that's 3, I know this is 3, and that's 3. And since that's 9, I also know this is 9. That still doesn't really help me that much. I really need to break this up. How can I break this up?
You can break it up by 3 by 3 squares.
I could break it up into all squares.
Or you could break it up one into rectangle.
I could break this into rectangle by dropping the line here and dropping the line here. I could have also taken a line over here and over here. And if I did both of those, then I would have exactly what Alex said to begin with, just make a little square. But I'm going to go ahead and use the rectangle. I'm just going to back that one. There we go. So I'm just going to look at this as rectangle to make it a little bit more math. So this rectangle has a height of 9 and a width of 3. So that area is going to become 9 times 3, or 27. Now wait, crap. How do I figure out this length right here?
You just add two sides right.
I know that this is 3 and this is 3, so it's 6. Or like I just heard Emma say, I knew that this was 9 and this 3 gets taken away from it. So either way, that tells me that this is 6. So now I have a height of 6 and a width of 3. So 6 times 3 tells me the area for this space. 6 times 3, 18. And then this space is just a square. 3 by 3 times 3 is 9. I add all these together. Well, 18 plus 9 is 27. So I really just have 27 plus 27, which gives me 54. Check for units. I have centimeters. So centimeters squared. And of course that is our area. So, if you have any questions, comments, or concerns, please put them in the discussion board, or message me or whatever else. The notes are available here in the classroom. I will make sure they're in the Schoology folder, and the homework is here as well. So please let me know if you find anything missing too. I know that people have been letting me know if files are missing, or whatever else. Otherwise, keep working hard. Have a great day, guys.